This is the Treasury Direct Issued Maturing report that I share on Twitter sometimes. The change column under bills shows you the net issuance for bills. This is for any given day, what was issued minus what matured. So for example, on April 9th, you can see net issuance was negative 36 billion because 206 was issued, but 242 matured. We have these net issuance columns, the change column for bills, notes, and bonds, plus the total for the day. That's the combination of all of them. That script, or the report, is generated by a script that's written in PowerShell, and it queries the Treasury Direct API to gather that data. Now, the fiscaldata.treasury.gov site also provides that same Treasury auctions data. In my experience, this data API is very friendly for doing bulk downloads of all the data going back to the 70s. So let's take a look at how to query that data through this API using Python and Pandas. First, I'll run this line to query the data, or rather, query the API for the data. Now, if we look at the resulting data frame, we can see here the data goes back to 1979 and includes all the way to the present. You can also see that there are many columns, but what you see here, that's not all the columns. Let's display one row from this table and show all of the fields in that row. So we'll evaluate this. I've expanded the terminal window so you can see the results. So starting about here, where we're printing the row, everything below that, this is all the data you get with every single record for the auction data, table. So clearly you get a lot of information back for each auction. However, we're going to focus on a few columns and I'll display them here. So now we're just looking at the issue date for every auction. We're looking at the issue date, the maturity date, the security type, and the total accepted. These next three lines convert certain columns, these two columns into data types, and this column into a numeric type. Before we did the conversion, for example, on this line, this column would just show up as type object, and after we do the conversion, it's actually going to show up as a date time data type. Now, if we look at the data frame, we can see, for example, let's look at these rows right here. So I'm highlighting April 2nd. We're going to see there's issuance of bills, and here are the amounts. And what I want to point out is that on any given day, you can have multiple auctions for a security type. So in this case, we're having 3 different auctions, all of bills. What we want to do is combine all of those into one row so that we can know on April 2nd what was the total accepted amount for bills only. And that's what this line does. So there we're saying to group by issue date and security type and sum the total accepted amount. We stored that into this issued variable, and there we can see the resulting data frame. And now we can see for every date and every security type how much was issued on that day. This line does the same thing except for the maturity date, so that we can know on any given date how much matured for a particular security type. If we take a look at it, there's the resulting table or data frame. So again, for this line, we know that in the year 2053, on May 15th, total maturing bonds is this amount. Even if there was multiple auctions that ended up maturing on this day, we have them all combined into one row. So we have our issued data frame and our maturing data frame, and in In traditional database systems, you have a notion of a join, where you can join two different tables. Well, we'd effectively like to join these two data frames in a similar manner. We'd like to join them so that the issue date from issued, or we want to join the tables so that the issue date and the maturity date match. We also want the security types to be the same. So that's what this line is specifying. There are going to be days where there is issuance, but nothing's maturing, and vice versa. There may be days where there's some that's maturing, but there's nothing issuing. And on those particular rows, you'll have a maturity date. You won't have a matching issue date, and vice versa. You might have some where you have an issue date, but you don't have a corresponding maturity date. So that's why we're doing an outer join. Let's go ahead and run that. If we take a look at the resulting table, we can see the columns are issue date, security type, total accepted X, maturity date, total accepted Y. Whenever we do the merge, both issued and matured, or the maturing table, have a total accepted column, and so by default it's naming the total accepted from issued total accepted X, and the total accepted from the maturing table, it's calling that total accepted Y. So let's rename them total accepted X to issued and total accepted Y to maturing. So here's the resulting table, and it's issue date, security type, issued amount, maturity date, and then maturing amount. Now remember, net issuance is going to be issued minus maturing, so let's set up a column for that. This line sets it up, and I've displayed the resulting table here. So we have all the same columns, but now additionally we have a new change column, which is issued minus maturing. As I mentioned, sometimes you'll have rows where there's an issue date but not a maturity date, and you'll have other times where you have a maturity date but not an issue date. Let's add a new column which, if you have a value on both, which they're going to be the same, issue date and maturity date, we're going to use that value. If there's only an issue date, we'll use that, and if there's only a maturity date, we'll use that. So this line here sets that up. I've added a new column called date. This line here will leave us with just the following columns: date, security type, and change. And you can see under security type, of course, we have all the different security types: bonds, bills, notes, etc. And what we want to end up is, we want to pivot this table so that every security type gets its own column, and the column will show you the net issuance. That's what this line right here does. We're saying we want to do a pivot. The columns are going to come from the security type column and from the initial table, and the values are going to be the change. So we ended up with this, we stored that in pivot df, and this is what it looks like. There we can see each security type gets its own column, which is showing the net issuance, which comes from the change column. In this video, I wanted to focus on how to do the data transformations within Python Pandas. The rest of the script is for plotting the data, so I won't go into that here. But I will show you the resulting chart. This is what it looks like. And it's completely zoomed out, so we're seeing the auction data all the way from the 70s. Right here you can see there's, so this is the zero value. Obviously positive is going to be positive net issuance, negative bars are going to be negative net issuance. And here's a particular, or kind of peculiar area where you can see all of a sudden that net issuance stops. That's because there's no issuance, of course, yet into the future. And so here we only see maturing amounts. So for example, here are the colors, right? Blue is bonds. There we can see lots of bonds maturing in the future. Here we can see some shorter terms items. All the green are notes. So we have notes, FRN notes, TIPS notes, different kinds of notes. Those are all maturing here. So that's why you see these negative values in the future. So if we use this zoom tool on the side, let's just pick, let's say, this section of data. Now that we're zoomed in, we can use the legend here to turn off, to toggle different security types. So I'm actually going to turn off notes and bonds and just leave the orange ones, which are bills and CMBs, different kinds of bills, so that we can focus on bill issuance. Here we can see in 2020, around the time of COVID, there was a lot of issuance for bills, and then a lot of bills issuance started to happen again in 2023.